Lesson 19.4, Task 1. Compare quadratic functions. Analyze different forms of quadratic functions. You have learned how to write quadratic functions in standard form, vertex form, and intercept form. Each form gives you different information about some key characteristics of the function's graph. The quadratic function represented by the graph is written in three forms. All right, so this is the same equation written in three different forms. So in standard form, you've got f of x. In vertex form, you've got f of x again. And in intercept form, you have f of x again. All right, so this is the graph of f of x. And it says, which form would you use to determine the x-intercepts of the graph, the minimum value of the function, or the y-intercept of the graph? Match each characteristic of the graph to the form you would use to determine. All right, so if you look at this, the intercepts, x minus 4 is going to cross at 4, and x minus 20 crosses at 20. So 4 and 20, your intercepts, come from intercept form. Remember, the vertex form determines the vertex. So at 12 and negative 32 over 5, so this would be at 12 and down. It's a fraction. You can see it's just past 6, and that makes sense since 6 times 5 is 30 and 2/5 left over. So that would be negative 6 and 2/5. And then standard form gives you your intercept. So 8 comes from the y-intercept in standard form. All right, so the x-intercepts come from intercept form. The name kind of gives it away. The minimum comes from your vertex, so that would come from vertex form. And the y-intercept comes from standard form. Again, you can see the y-intercept where it crosses here, and that comes from the last part, your constant term in standard form. So each equation lets you see and determine different things that are helpful when looking at the equation. All right, so it says compare the table, put an X if in each cell for which the key characteristics of the graph can be determined by only looking at the corresponding form of the quadratic function. Put a 0 or an O if it cannot. All right, so put an X if a key characteristic can be determined. All right, so we've got standard form, vertex form, and intercept form. These are the same equations from above, but we want to know in standard form, can you tell if the parabola opens up or down? The answer is yes, because the sign of your leading coefficient tells you if it's positive, it goes up. If it's negative, it goes down. All right. What about vertex form? In vertex form, yes, again, you can tell whether it goes up or down. So this would also be an X. And then in intercept form, same thing. You can tell that that is positive and it goes up. All right, so axis of symmetry. So in standard form, your axis of symmetry I would think that you have to find the vertex first, so I'm not sure why they have an X there, but let's look at vertex form. So the axis of symmetry goes through your vertex, so it's going to go through 12 and negative 32 over 5, so that one would be an X here. And then in intercept form, can you easily see the axis of symmetry? And that one would be no, you cannot easily see. You can see the x-intercepts, but not the vertex from there. All right, the vertex. Can you see the vertex from standard form? And I'm going to put no. You cannot. You have to do negative b over 2a and then plug x in to find y to find your vertex. So it's not easily seen there. All right, is the vertex easy in vertex form? Well, it is called vertex form. So 12 and negative 32 over 5 is the vertex. So that one would be yes. And is the vertex easy to see in intercept form? And that one would be no. All right, the intercepts. Well, we know the intercepts are easy to see in intercept form, but what about vertex form or standard form? So both of these would be no. All right, your y-intercept. We can see the y-intercept in standard form, so this one would be a yes, but the y-intercept is not visible in the other two forms. All right, so I really think this one right here is incorrect. The axis of symmetry comes from your vertex, and the fact that you cannot see the vertex, I feel like this one should be an O as well. But anyways, that's all for that question. So let's look at the next one. Do the functions rules for each form have any single quantity in common? If so, what does these quantities tell you about the graph of the function? All right, so if you look at these, you can see that each one of them has the 1/10 out front. So that is your A value. That does tell you if it turns up or down, depending on whether it's positive or negative. And it also tells you if it has a compression or if it shrinks or expands based on the number A here. So everything else is different, but the A does tell you that about the graph. All right, that's all for task 1. If you have any questions, let me know. Lesson 19.4, task 2. Compare quadratic functions with different representations. The graphs of quadratic functions f and g are parabolas that open up. Which function has the lesser minimum value? All right, so you can see f of x is in vertex form, so we can easily see that the vertex is 5, -6. G of x is given to us in a table. So we have 10, 0, 0, 10, so we know that the vertex is going to fall in between -1 and 3. All right, so we'll have to find that value. But these are the 4 points that we're given. We're not given the vertex, but we can find it easily. So start by finding the vertex of the graph of each function. Okay, again, this one's given. This one we're going to have to find. All right, so how can the vertex of the graph of the function be used to find the minimum value of the function? All right, so you know the x of the vertex is your axis of symmetry. The y value is your minimum or maximum value. So it says the x coordinate, the y coordinate. So the y coordinate of the vertex is the minimum value of the function. And that's the only one that it could be. All right, it says find the vertex of the graph of f. All right, the vertex of the graph of f is given because it's in vertex form. So remember it's a times x minus h, quantity squared plus k. So it's going to be opposite h, so it's going to be 5 and -6. So your vertex is 5 and -6. That comes straight from vertex form. So it says, how is the vertex found using the vertex form of the function? For a function in vertex form, f of x equals a times x minus h squared plus k, and the vertex is hk. So this one, okay, so these are the same, but this is not negative. It's just hk is your vertex. All right, so now it says find the vertex of the graph of G. So it says points -1, 0, and 3, 0 in the table show that the graph of the function has x-intercepts at -1 and 3. Use these values to write the function in intercept form. So if we do that, we're going to have g of x equals a times x plus 1, because it's going to be opposite this, because we're writing it as a factor. This is the 0. And then we're going to have x minus 3, same thing. You write it as a factor, so the sign is backwards. And this is called intercept form. Now, we also need to find a. So to do that, we're going to have to find another value, or another point from our table and plug it in. So we know g of x is the same thing as y equals, this is just function notation, and we have x. So if we have an x and a y value, we can plug the x and y in and solve for a. So that's what we're going to do. So if you look back up here at the table, we know that these are the two intercepts that were used. These are the two intercepts that gave us our two factors. So we can use this point or this point in order to find a. All right, so let's see what they did. So they used 4, 10. So 4, 10 was a point from the table. And they plugged 4 in for both x's, and they plugged 10 in for y, or g of x. Okay? So then you just solve. So if you got 4 plus 1 is 5. 4 minus 3 is 1. So that's going to leave 5 times 1, which is just 5a. That's where this comes from here. And then divide both sides by 5, you get 2. So they quickly found a by just using a third point from that table. So now you can take the same factors here and now use the a value to write it in intercept form. So g of x equals 2 times x plus 1 times x minus 3, and this is g of x in intercept form. What point, x and y on the graph of the function, was used to find the value of a? All right, so they used the point. You can see 4, 10. They used the point, just the ordered pair, 4 and 10, to plug it in on the graph of the function from the table to find a. All right, it says use the intercept form of the function to find the axis of symmetry of its graph. All right, the axis of symmetry is going to be the average of those x values. So -1 plus 3, again, that comes from the two x values from the zeros here. So the -1 and 3, we know these are the zeros because the y values are zeros. So we're going to take those and average it, and we know the vertex is going to be in the center of that. So anytime you find the average, that gets the middle value there. So the axis of symmetry is going to be x equals 1. And then all you have to do is plug 1 into your equation for x, and that gives you your y value. All right, so 1 and -8 is the vertex. All right, so it says, how was the y-coordinate of the vertex of the graph G found? Select the correct value to complete the sentence. The x-coordinate of the vertex, 1, we just found that right here, was substituted into the function to evaluate the corresponding y value. So again, we plugged x in and solved for y. All right, so now it says compare the vertices. The minimum value of function f is -6. Okay, you can see that right here. The minimum value of f, which is the blue one, is -6. And the minimum value of g is -8. So function g has the lesser minimum value. Okay, the graphs of the functions shown that g has a lesser minimum value since the vertex of its graph is lower. So again, when you look at the picture, it's a visual image. You can see that this one is less or it is lower on the graph. All right, that's all for task 2. If you have any questions, let me know.